What's up guys? This is Youngno. Let's solve this question. In this question we have a system of equations, but since these equations they look kind of ugly, so why don't we just isolate y from each equation. So first equation, I'm just gonna move this 2y to the left hand side. So we have 3y minus 2y, which is just y, and I'm just gonna move that negative 5x thing to the right hand side. Then on the right hand side we have negative 3x and plus 5x, that is positive 2x, and we have 5. We isolated y from the first equation. Now it looks way better. Let's do the similar job to the second equation. I'm gonna move that negative 3x term to the right hand side so that we can have only y on the left hand side. So on the right hand side we have quadratic term kx squared, negative 3x is now positive 3x, and 17. Why don't we just solve this system? You can simply set them equal. Once you move all the terms to the other side, we have quadratic. For the linear, we have 3x and minus 2x, which is just x, and 17 minus 5, that is 12, equal to 0. We have an equation, which is quadratic. But you know what? Since the system is guaranteed to have no solution, this quadratic equation is also guaranteed to have no solution. When it comes to the number of solution of a given quadratic equation, discriminant is extremely helpful. Let me give you a brief introduction on discriminant. Whenever you have a quadratic equation in its standard form, the ABC form, then you can define discriminant, usually represented as capital D, which is b squared minus 4ac. If this d value is positive, then the given quadratic equation is supposed to have two distinct real solutions. If this d is equal to 0, then the given equation has only one distinct real solution, and if d is negative, there's no real solution. The reason why this discriminant is extremely important is it gives you the number of real solutions to the given quadratic equation. Since we already know that this quadratic equation has no solution, discriminant of this equation, it's guaranteed to be negative. So let's define d. b is 1 here, so 1 squared minus 4, a is k, and c is 12. So discriminant is simply 1 minus 48k, and as we already figured out, it has to be negative. Now it all comes down to solving this inequality. Let's move negative 40k to the right hand side. Then we have 1 less than 48k, and why don't we just divide both sides by 48? Since we divided a positive number, direction of that inequality stays the same. K is an integer, and we're looking for smallest possible value of k. Since 1 over 48 is some positive number that is smaller than 1, so it's something like 0 point something, the smallest possible integer value for k has to be 1. That's the final answer. We're done. See you on the next question.